8 earthquakes in 9 hours. Not spread across a country, not spread across a region, but packed inside a single 90-kilometer strip of ocean floor off the coast of southern Mexico. And the strangest part is not the number itself, it is the timing behind it. It is that scientists had already called this sequence finished, based on everything the data appeared to show. That call was wrong. By the end of this video, you are going to understand exactly why a fault that was supposed to be quieting down instead did the opposite. Instead, it produced one of its strongest aftershocks a full 24 hours after seismologists had already said the danger was fading. This is not a normal aftershock story, and the reason why sits inside data two major agencies cannot even agree on. Start with what happened first, because the opening hours followed the textbook almost perfectly, the way seismologists expect a subduction zone rupture of this size to unfold. On July 17, 2026, a magnitude 7.3 earthquake ruptured the Middle America Trench off Chiapas in southern Mexico. 6 million people felt it immediately. The rupture sat at a shallow depth of only 15 kilometers according to initial readings released shortly after the event. Shallow earthquakes shake harder at the surface because the energy has less rock to travel through before it reaches you. 6 million people across Mexico, Guatemala, and El Salvador experienced shaking strong enough to notice, strong enough to send people into the streets, strong enough to be genuinely frightened by, even in regions accustomed to regular seismic activity throughout their entire lives. Within minutes, the Pacific Tsunami Warning Center issued a hazardous tsunami warning for the coastline. Coastal evacuations are not a small decision. They shut down highways, they empty hotels, they move fishing fleets away from harbor without hesitation. Officials stood the warning down after review, once wave height data came back below the danger threshold. But for those first tense minutes, nobody watching the coastline knew that yet, and the uncertainty alone was enough to matter, enough to send families toward higher ground on instinct alone. Here's the part that matters more than the headline number. Before the main shock even happened, the fault was already talking. A magnitude 4.74 shock struck 88 minutes before the larger earthquake arrived. 4 shocks like that are common in hindsight and almost impossible to identify in the moment they happen. Only after the larger earthquake occurs does a small tremor beforehand earn the label foreshock instead of simply background noise from a restless coastline. Then came the aftershocks, and this is where the sequence still looked completely ordinary to anyone watching the data feed closely. At least 10 aftershocks, ranging from magnitude 4.9 up to 6.0, followed throughout that first Friday alone. Every major earthquake produces aftershocks. That is not unusual. That is physics settling. Stress redistributing itself along the fault plane as the crust adjusts to the sudden release of energy from the main rupture hours earlier, the way a struck bell keeps ringing after the initial hit. By Saturday, seismologists tracking the sequence described it in almost dismissive terms, using the kind of language reserved for routine events, entirely ordinary, expected to fade. That is the standard language used for a fault that has released its energy and is winding down toward silence. That is the language used the way nearly every aftershock sequence on Earth eventually winds down, following a well-understood decay pattern that seismologists have documented across thousands of earthquakes over more than a century of recorded seismic data worldwide. Then it did not fade. It got louder. Across roughly 9 hours spanning Saturday evening into early Sunday morning, at least 8 separate earthquakes of magnitude 4.5 or greater were cataloged in a single tight cluster. All 8 sat inside that same tight 90-kilometer zone off Chiapas, the exact patch of seafloor that had just been assessed as calming down. Sit with that shape for a second before moving forward. Not one anomaly. Not a single unexpected jolt breaking an otherwise clean pattern. 8 of them, back-to-back inside a single overnight window, in a sequence that respected seismologists had just finished describing as calming down completely and reliably. That is not how aftershock decay is supposed to look on paper. And it is not how it has looked in the vast majority of comparable sequences studied by seismologists across similar subduction zones worldwide over many decades. And the strongest of those 8 was not the first one in the cluster. It was the largest one, a magnitude 5.7, and it arrived last, after everyone had already downgraded their concern the day before. It arrived a full 24 hours after the sequence had already been assessed as winding down by the scientists watching it closest. The fault got stronger after scientists said it was getting weaker, not the other way around, exactly backwards from expectation. Now zoom out to the planet as a whole, because this is where the story stops being a local Mexican news item. It becomes something seismologists everywhere are quietly watching with real attention this week, comparing notes across institutions and time zones as the data keeps arriving. Earth logs earthquakes constantly, every single day, across every continent. Most weeks, the global count of magnitude 4.5 or larger events comes from dozens of different fault zones scattered across every continent on the planet. Not this week. The 7-day worldwide count of earthquakes at magnitude 4.5 and above rose by 7 events across that same interval, an unusually concentrated spike that immediately stood out to anyone monitoring the global feed in real time. That single patch of seafloor off Chiapas accounts for essentially the entire global increase, all by itself, without meaningful contribution from any other fault zone anywhere else on the planet during that same 7-day monitoring window, which is genuinely rare. Think about the scale mismatch there for a moment. Earth has roughly 40,000 kilometers of active plate boundary wrapped around the planet, threading through the Pacific, the Himalayas, the mid-ocean ridges, and the Mediterranean, crossing dozens of countries and cultures along the way. Nearly every new moderate earthquake logged anywhere on Earth this week came from one small box of ocean floor, a box you could drive across in under an hour on a clear road. That is the kind of statistical anomaly that makes a seismologist stop scrolling and start reading the bulletins closely, twice, checking timestamps against each other to make sure the pattern is real and not a reporting artifact. One patch of crust outproducing the rest of the planet combined is not something you see in an ordinary week, and it is not something that resolves itself quietly with a shrug from the scientific community. So naturally, the next question is simple. What exactly is happening down there underneath that specific stretch of ocean floor? And this is where the story runs directly into a wall of disagreement. The one measurement that would answer it does not currently exist in agreement between agencies. The depth of the earthquake is disputed, and the disagreement between the two organizations tracking it is not small at all. The United States Geological Survey places the main event at a depth of 15 kilometers based on their seismic modeling. The European Mediterranean Seismological Center places it nearly twice as deep, at 25 kilometers instead, using the same waveform data run through a different velocity model. That gap of 10 kilometers sounds technical, almost like rounding error to someone outside the field. It is not rounding error. It changes which fault structure is actually considered responsible for generating this entire sequence beneath the ocean floor. Here is why depth decides everything in a case like this one. A sequence clustered on the shallow interface, the boundary where one tectonic plate slides directly beneath another, tells a very specific story. That shallow geometry is exactly the setting in which foreshock sequences occur before the largest earthquakes on the planet, the ones capable of producing magnitude 8 megathrust ruptures that reshape coastlines in seconds. A sequence sitting deeper inside the descending slab itself, rather than on the boundary between plates, is a completely different physical process entirely, governed by different stresses and different failure mechanics deep underground. It behaves differently, it decays differently, and critically, it does not carry the same risk of triggering a much larger rupture on the shallow interface sitting above it, closer to the surface and to population centers. Right now, that answer does not exist for certain. Two respected agencies, using the same raw seismic data recorded by the same global network of instruments, have produced depth estimates that disagree by nearly a factor of 3. Until that gap closes, nobody can say with real confidence which of those two very different fault behaviors is actually driving the sequence beneath Chiapas, and that uncertainty is not a small detail to set aside or dismiss. To understand why this matters this much, you need the historical benchmark for the region, the number every seismologist studying Chiapas keeps in the back of their mind whenever a new rupture occurs nearby. The largest recorded earthquake in Mexico's modern history was the magnitude 8.1 Chiapas earthquake of 2017, a genuinely historic rupture that caused widespread damage and was felt across the entire country, from the coast all the way to the capital. Today's magnitude 7.3 event sits within one single magnitude unit of that historical record. Close enough that comparisons are inevitable among anyone who lived through or studied the 2017 disaster. On the logarithmic scale seismologists use to measure earthquake energy, one magnitude unit represents roughly a 32-fold difference in total energy release, which is a genuinely enormous gap in real physical terms. This event is close enough to that benchmark to draw a direct comparison in conversation, but not close enough in raw energy to equal the historic 2017 rupture that Mexico still remembers vividly today, years later. Seismologists tracking the sequence have not stayed silent about the risk involved, and that transparency is worth noting. They have named one specific, falsifiable threshold out loud for the public to watch alongside them. It is the kind of clear line that lets anyone, expert or casual observer, judge the situation for themselves as new data arrives, rather than relying on vague reassurance handed down from an agency press release. That threshold is this. If multiple earthquakes of magnitude 6.0 or greater begin appearing anywhere inside this sequence, the assessment changes immediately, from a productive but ordinary aftershock sequence to something else entirely. It changes to something that warrants far more concern and far closer monitoring from every agency involved, including emergency planners across 3 separate countries who would need to coordinate a response almost immediately without the luxury of days to prepare. As of now, that threshold has not been crossed by this sequence. The largest single event remains the magnitude 5.7 aftershock, serious in its own right, unusual in its timing, but still below the drawn line. It remains below the line seismologists themselves drew as the point of real alarm for this specific fault system. That distinction matters enormously, and it is worth holding on to as new updates continue arriving daily from multiple monitoring stations. But here is the sentence that should stay with you longer than any single number mentioned anywhere in this entire video. The sequence was supposed to be fading, and everyone watching it agreed on that. Seismologists said so publicly on Saturday, using language that suggested the danger was passing. Instead, it produced 8 earthquakes in 9 hours, capped by its strongest aftershock arriving a full day later than expected. That is not a prediction failing by a small margin or a rounding error buried somewhere in a model. That is a fault behaving in a way that ran directly against the working assessment of the people watching it closest, in real time. Those are people using the best instruments and the best models available anywhere on the planet right now, backed by decades of prior earthquake data from this exact stretch of the Mexican coastline and beyond. So where does this leave things as of today? The depth dispute between USGS and the European Mediterranean Seismological Center remains completely unresolved, with no new joint statement narrowing that 10-kilometer gap yet. Until it resolves, nobody can confidently rule the shallow megathrust interface in or out as the structure generating this activity beneath the seafloor off Chiapas, and that ambiguity shapes every risk conversation happening right now among the scientists involved. The global earthquake count for the week remains dominated almost entirely by this one sequence, an imbalance that is itself a signal worth tracking, regardless of what happens next in the region over the coming days. And the 6-0 threshold the line seismologists themselves chose as the marker between ordinary and concerning has not been crossed, but it has also not moved further out of reach after this weekend. It has not moved further away, not after a sequence that just spent 9 hours refusing to follow its own forecast, defying the exact language used to describe it only hours earlier by the people tracking it. None of this means catastrophe is coming, and nothing here is a prediction of disaster. It also does not mean the story is finished, or that attention should move elsewhere starting tomorrow morning. It means the fault off Chiapas did something this weekend that contradicted the working model, and the two agencies responsible for measuring it cannot yet agree on the basic geometry driving the entire sequence forward from here. If this kind of real-time breakdown between measurement and expectation is something you want to understand as it happens, rather than after the headline simplifies it for you, keep watching closely over these next few days as this story continues unfolding. This is exactly the kind of event worth watching as new depth data comes in from both agencies, and as the aftershock count either climbs toward that 6-0 threshold or finally begins the fade everyone expected days ago, one way or another. Subscribe if you want the next update the moment the depth dispute resolves, or the moment that magnitude 6 threshold gets tested for the first time since this sequence began late last week off the Mexican coast. Because when it happens, it will happen fast and without much warning. This sequence is not finished telling its story, and neither are we, because a fault that breaks its own forecast once is a fault worth watching until it finally settles for good, however long that actually takes to happen.